Hey everybody, good to be with you again. Mr. Reeves back to solve a few more problems using the elimination method. I mentioned at the end of my last video that I wanted to find some more of the more challenging problems. So I went into IXL and I had to get all the way to a score of 96. Are you proud of me? I'm all the way at 96 before I got to one of these more difficult problems. So what do I mean by one of the more difficult problems? So remember, when we're using the elimination method, what we want to have is we want to have a pair of opposites if we're going to add, or a pair that are the same if we're going to subtract. And if you're paying attention in my last video, you heard me say that I recommend always create a pair of opposites and use addition because students make less mistakes when they are using addition than subtraction. All right, so we look at our terms and we say, okay, I want to create a pair of opposites. And we've been looking for a pair of multiples, right? Like 1 goes into 2, or 5 goes into 15, or 7 goes into 21, or that kind of thing. But if you take a look at this example, 4 is not a multiple of 3, and 3 is not a multiple of 4. And 8 is not a multiple of 10, and 10 is not a multiple of 8, right? So in this situation, we're going to go ahead and we're going to look at what our options are. All right, so one option, when I look at this right here, do you know what I see? I see that all of these are multiples of 2. So one option you can look at is say, well, if I divide, could I then create one where one's a multiple of each other? But when I look at this and I say, okay, if I divide this by 2, what's this going to become? It's going to become 5, right? And this is going to become negative 2, and those still are not going to be multiples. So I'm not going to go with division. I'm going to say, okay, well, if 10 is not a multiple of 8, what are 8 and 10 both multiples of? What is the number that 8 and 10 both go into? Sorry, what are 8 and 10 both factors of? Or what numbers, like I said, do 8 and 10 both go into? All right, and if you know your multiplication tables, or if you just start counting by 10, 10, 20, 30, 40, and if you go by 8, 8, 16, 24, 32, 40, you hopefully quickly see that 10 and 8 both are factors of 40. They both go into 40. And how many times does 10 go into 40? 4 times, right? So if I multiply this top equation by 4, I love that I have all this empty space here to work with. All right, I get negative 16x plus 40y equals negative, let's see here, 4 times negative 14. Let's see, that's going to be 56. Again, you're welcome to use a calculator if you need to. If you needed to go 4 times negative 14 to see what the answer is, it is negative 56. That's awesome. All right. Now, again, what do I want down here? I want it to be negative 40 because I'm looking for those pair of opposites so that when I add, what's going to happen? They're going to what? They're going to cancel. Now, again, how many times does 8 go into 40? 8 times 5, right? But remember, I don't want a positive 40. I want a negative 40. If I was going to subtract, they could both be positive. So what am I going to multiply? I'm not going to multiply by 5 alone. I'm going to multiply by negative 5. And again, I'm going to multiply everything here by that negative 5. All right, so when we do that, I get 15x minus 40y equals what is a negative 5 times a negative 13. It is a positive 65. Again, if you weren't sure, you can use your calculator. A negative 5 times a negative 13 is going to give me a positive 65 as my answer. And now I'm ready to add these together. When I do that, a negative 16x plus positive 15x gives me 1x. Again, those cancel. That's why I did it. And when I do a negative 56 plus a positive 65, again, feel free to use your calculator if you need to, negative 56 plus positive 65, I get a positive 9. So x is equal to 9. Now the question is, what does y equal? What does y equal? All right, so again, if you've been paying attention, you know that you go back to one of your two equations, your original. You also can use these ones, but I always recommend going back to one of your original ones. I'm just going to go ahead and use my top equation. Negative 4x plus 10y equals negative 14. Now, I didn't used to know what x or y are, but now I know that x is 9. So I'm going to go right here, negative 4 times 9 plus 10 times y equals negative 14. So I get negative 36 plus 10y equals negative 14. All right, so what's going to happen now? I'm going to add 36 to both sides. And when I do that, I get 10y equals, well, 36 take away 14 is going to be 22, right? But again, if you need to use your calculator because you're not sure, we could do that. We can put in negative 14 plus positive 36, and you'll see that Mr. Reeves was right. He actually got 22. All right, now when I put this in, I'm a little bit concerned because what happened? All right, 10 does not go into 22 evenly. And when I do that, I get 22 divided by 10 is 2.2 as a decimal, or if I simplified it, I would get 11/5, right? Because if I divide this one by 2 and this one by 2. All right, so I'm always a little bit concerned when I get a fraction or a decimal answer that maybe I made a mistake. But the great thing about system of equations is you can always check your answer. So I use the top equation, right? Well, I'm going to go to the bottom equation here, and I'm going to go negative 3x plus 8y is equal to negative 13. And again, what am I saying my solution is? All right, I'm saying that my solution is 9 and 2.2, or 9 if you prefer the fraction, and 11/5. So I'm going to go right here, and in place of x, I'm going to put 9, and in place of y, I'm going to put 2.2. I'm going to go ahead and use the decimal. And here we go. I get negative 27 plus, I'm going to go ahead and go to my calculator. And I'm going to do, let's see here, 8 times 2.2 equals 17.6. And what do I realize? I realize that that answer is incorrect. Well, this is the first time this has ever happened. I made a mistake. I checked my answer and it didn't turn out to be correct. Ouch, it's wrong. All right, so let me go back and see if I can find my mistake, because mistakes are going to happen sometimes, right? Even math teachers make mistakes. So I'm going to go back up to the very beginning, and let's see what happens here. Okay, so I had 4 times negative 4, negative 16x. That looks good. I have 4 times 10y. That's 40y. That looks good. I have 4 times negative 14. I think I did that one on the calculator, right? 4 times negative 14 is negative 56. So far, so good. All right, my next one down here, I multiplied this equation by negative 5. A negative 5 times a negative 3 is a 15x, right? A negative 5 times an 8y is negative 40y, and a negative 5 times a negative 13, I've got 65. Let me double check that math right there. I'm pretty sure that's right, right? What do? We have a negative 5, right, times a negative 13. Yeah, and I get a positive 65. Okay, so far I'm not seeing any mistakes. Here we go. Then I'm going to add these together. So negative 16, there it is. There's my mistake. I bet some of you were like screaming at me earlier when you were watching this video going, wait, that's wrong. A negative 16x plus a positive 15y is going to give me what? A negative 1x. A negative 1x is equal to 9. So what does x equal? X does not equal positive 9. X equals negative 9. X equals negative 9. So that means this process right here, when I did that, that's all wrong. And I'm going to erase my check because that is all wrong. And I'm going to erase these because that is wrong. So I'm going to go back right here and I'm going to go negative 4 times negative 9, right? And a negative 4 times a negative 9 is a positive 36 plus 10y is equal to negative 14. All right, then I'm going to subtract 36 from both sides and I get 10y equals and a negative 14. All right, take away 36, or actually, right, when I add a negative 14 plus a negative 36, I get negative 50, right? Okay, and I'm liking this a little better because I get y is negative 5. All right. So I'm a little more confident in my answer. Now, I do want to tell you that every time you get a fraction or a decimal answer, that does not mean you made a mistake. Many times you can get a fraction or a decimal answer to systems of equations problems. But in general, they try to make them come out usually with integer values more often than fraction or decimal values, especially at this level where we're at in 8th grade math. All right, so I found that answer from the first equation. I'm going to check it in the second equation. Negative 3x plus 8y equals negative 13. All right, so then I'm going to check my answer. What did we say that x was? I don't know why I have it twice anymore. X is 9, and y is what? Negative 5, and I'm hoping to get negative 13. I get negative 27. Oh my goodness. Oh my goodness. Mr. Reeves is making all kinds of mistakes. There's so many opportunities to make mistakes. X is not positive 9. X is what? Negative 9. Negative 3 times negative 9 plus 8 times negative 5. Sometimes, guys, you're just a little off your game. That's why checking your answers is so important. All right, negative 3 times negative 9 is positive 27 plus negative 40. All right, now I'm liking life a little better because when you add 27 plus negative 40, guess what you get? You get negative 13. So the answer is negative 9, Mr. Reeves, and negative 5. Let's see if IXL agrees with us. I'm going to go ahead and put in negative 9 for X, and I'm going to put in, it's fighting me here, negative 5 for Y, and let's see what the magic IXL says. It says to keep it up. Look at that, I'm at 98, and I've only answered one question. Are you impressed? I got a score of 98 with one question. Okay, let's see if I can get this one right. And then we can end this video on a positive note. I actually thought about starting over when I made that mistake, guys, but I wanted to let you know that mistakes are going to happen. Even math teachers make mistakes. That's why you should check your answers, all right? So all the other videos, every time I got it right every time, so I decided, you know what, I'm going to eat a little humble pie. I'm going to let students see that I made a mistake, but I caught my mistake because I checked my answer. All right, so here we go. All right, so I've got, once again, two equations I want to solve using elimination, which means I'm looking for a pair of opposites if I'm going to add, or a pair that are the same if I'm going to subtract. But since I'm Mr. Reeves, I'm going to always add, so I'm looking to create a pair of opposites. Now, 9 and 10 are not multiples of each other, and 4 and 5 are not multiples of each other, which means I'm going to have to multiply both equations. So I'm either going to find something 10 and 9 both go into, which I think 90 is probably my best option, or 5 and 4 both go into, which is what, 20? All right, so I'm going to go ahead and go with 5 and 4. So here we go. So I'm going to take my top equation, and what do I multiply 5 by to get 20? It's 4. So I'm going to take this top equation, I'm going to multiply everything by 4. Remember, everything gets multiplied by 4. So I get negative 40x, right? Plus 20y, 40x. Let me try that again. Negative 40x, right? Plus 20y equals 80. And on the bottom, I'm going to multiply by 5, except I want these to be opposites, right? So I'm going to multiply by a negative 5. And again, I'm going to do it to everything here, right? So here we go. So I'm going to get 45x, right? Because a negative 5 times a negative 9 is a positive 45x, right? Minus 20y, there's my opposites, equals negative, let's see, 5 times 14. Well, that's the same as 7 times 10, negative 70. Again, you could pull it up on your calculator if you needed to do that. And I'm adding because Mr. Reeves always uses addition when he has a choice. So then right here, those are going to cancel because they're opposites, right? What are 45 positives plus 40 negatives? I get 5x equals 10. And then what do? Then I divide by 5 and I get x is equal to 2. X is equal to 2. All right, so that 2 right there. So I've got my 2, but the question is, what is y? All right, so this is old hat by now, right? You know to go to one of your original equations, negative 10x plus 5y equals 20. When we started this problem, we did not know what x or y are, but we now know that if I put in a value of 2, that's my x value that's going to make both equations true. Now I want to find the y value that makes both equations true. Negative 10 times 2 is negative 20 plus 5y equals 20, right? So then I'm going to be adding 20 to both sides, and I'm going to get 5y is equal to 40, and then I'm going to divide by 5, and I get y is equal to 8. So I'm feeling pretty good about life right now. All right, 2, 8, I believe is the correct answer, but the great thing about systems of equations is you can always know. All right, so I use the top equation to find the value of y, so I'm going to use the bottom equation to check and see if my value of x and y makes this equation true. So negative 9 times 2 plus 4 times 8 has to equal 14. So here we go. Negative 9 times 2, negative 18 plus 32 equals 14. Does it? Negative 18 plus 32, does that equal 14? All right, it does, but let's go ahead and check that on our calculator. 32 plus negative 18, and what do I get? I get 14, which is what I was supposed to get. So what did we just find? We just found out that when you put 2 in for x and you put 8 in for y, you get the solution that makes this true. Negative 20 plus 40 equals, and it works. All right, and look at that. I earned a gold medal. All right, 2 questions and a smart score of 20. Try to beat that, boys and girls. All right, thanks for watching, including my mistake. All right, I hope you have a great day. Bye.